due date. If your program is not found, then the grade is a 0. I do allow resubmissions in cases like that. However, there's a penalty. The penalty is 15% for a resubmission. So if your program can't be found because you did something boneheaded, then it will cost you 15% to submit it. Also note that the grade applies to every person on the team equally. Now I make a big deal out of this because it's an eternal problem. And not so much this class, 310 is where it's a real problem. I have 80 students and 10 of them make hand-in mistakes. And then they all want me to let them off the hook and how much time gets eaten up going in and manually finding and retrieving those files. And I go in somebody's account to find their files and I say, I see P1, I see projects, I see source code. And inside each of those folders are files that might match. And then I see files working, good, save. Okay, which ones am I going to take and grade? All of them? And you get the best grade? No. So there's one place where your files go when you submit your project, and that is this place. So the act of copying your files into this folder, which you must create, indicates that you're submitting your assignment for grading. So don't put things in there unless you're ready to turn them in for grading. So you're going to do that, and then you're going to give me a printout of your source code files. Okay, so the assignment. We are going to write a file parser class. This is the first in the series or sequence of assignments we will have during the semester. We're going to be creating a macro preprocessor program. We have a live program we can compare it to. I expect it to behave exactly the same way as the production version that's running on Rohan and now on Edorus. But we've been using that program for about, I don't know, maybe 8 or 9 years now. And in case you think it's too hard and unfair, that program was written as a team project in CS530 by other students. And so the way this worked out, Professor Vinci was still here. He hadn't retired then. He asked me, he said, I'm always scrambling to find new projects to assign for my systems programming class. Do you have any ideas? And I said, yes, I have an idea. So suggested this macro preprocessor. It turns out to have been a great assignment for his class. They did it in Java. So, of course, the source code for that project is not available to you guys, but we have a working version that you can compare with. And the path for that, let's see here. Which one am I using? 0640. Yes, okay. Permission denied. Well, I'll have to open that up. I'm going to need that for my other class. Let's see. Let's try. Oops, I got some mistakes. Well, that's where it is. No such file address. All right. I can't spell. Gosh. File not found. Okay, so that's the location of the preprocessor. But anyway, I will give you links to this and tell you how to get to it so you can compare your output with the actual preprocessor that we're using in CS530 Sep. So you can always test your files and make sure that you're getting the right result. However, for this first project, what you're doing is you're parsing an assembly language source code file and busting it into tokens. So briefly here, every line of assembler, and thankfully this matches the text. There's some minor differences here, but the layout's about the same. Now what you have is columns. You have a label. And only labels and comments start in the first column, column 0. You have a label. You have an opcode or an assembler directive. And then you have operand and finally comments. Comments start with this or this. So we will talk about this in some detail, but what I want you to do for the first pass of this is to open the source code file and bust each line into tokens so that you have the ability to pull out line 4, token 2. So you're going to parse it and split them up. Label, opcode, operand, comment. So those are the 4 potential fields. There can be fewer than 4. You can have a line with just a label on it. There must be white space between each of the 4 fields. Labels must start in column 0 and are only letters or digits, and the first character has to be a letter. Comments is an asterisk or a semicolon. Finally, quoted characters are a single token, i.e. this. So there's no comment here. If there was a comment, it would be here, and that would be the 4th column. This is token number 1, number 2, number 3. This is one token, and there are no spaces inside tokens. That's not allowed unless it's in quote marks. So the hello world, of course, there's a space here, and that's legal, but it's quoted. So here's the prototype. We go over doing these today. We're going to talk about this stuff. This is the prototype. So different from Java, we have H files. This is a header file, and it has the prototypes of all the methods, and it also has your class definitions. Class file parser, notice it's not camel case, it's lowercase after lowercase. These are all methods that you have. You have a constructor that takes a string, which is the name of the file. Now the string here, which is the file name, will be a command line argument. It works the same way that Java does. There's a destructor. We'll talk about that. There's no automated garbage collection with C++. So if you allocate memory, you must also free it up. And that's the purpose of a destructor, is to free memory. Read a file and then get a token. This is the lookup method, get token. Notice that these are rows and columns and they're 0 based. So the first row is at 0. So 0, 0 is the first row, first token. They work like arrays work. This was on purpose. And then there's a print method where you print the 4, you print each of the tokens. And that's it. There's a size that tells you how many lines there are. And then a space for your private variables and methods, which are listed below. Those you can add whatever you need. There's an exception class. So something which goes wrong, you throw an exception, and it's this. You should pass a message or a string in if you throw an exception so that the user can print out a helpful error message. Now there's a twist to this, of course. When you throw an error, when you throw an exception, you really need to get good error messages. And a good error message is number 1, what's wrong? And number 2, where is it? Can you imagine working on a Java project and the compiler says there was an error. Would that make development harder? An error occurred. There's 5,000 lines of code. Where did the error occur? An error occurred. Good luck with that. Everybody's mad. Okay, well, a programmer is going to use this. Therefore, what you want to say is, line 62, the token is invalid, that kind of thing. Note that the line numbers are not zero-based. There is a first line and it is line number 1. It is line number 1. So, throw a helpful error message, and part of that I would consider absolutely essential is the line number in the source code file where this occurred. If the user opens that file in an editor, then the line numbers better match, including blank lines, which are legal. I mean, you always leave blank lines in the source code when you program. So that's included. All right. So grading, code quality, conformance to C++ standards, processes correctly formatted source code without error. Now this would seem obvious and kind of like, well, of course, but it's amazing how many times I have seen programs that fail to process correct code. And it's lack of testing that causes these problems. And if I provide really rigorous test files, then the grades are good. And if I don't, I just give examples and say, you tested, the grades are dreadful. So somewhere in the middle, I think we're going to aim for, but the best grades will come from groups that test things that I did not test in the sample code that I provide to you. So you'll have to think about what could go wrong and what could go right. What's not being tested to make sure it works. Okay, so detects formatting errors and prints helpful diagnostic messages. Now, there's some errors you cannot check. There's some things you can't do at this point because what do you know about the source code file? What do you know? Well, basically nothing. So, okay, only labels or comments can start here. So if you have something like this, is it an error? You can't put an opcode there. So should you catch this and put an error message? And the answer is no. No. How are you going to validate the label? It starts with a letter. It has only letters and digits. It's 8 characters or fewer. If it passes that test, it's valid. Therefore, this is valid. And in fact, you can do this. You can use the names of instructions as labels if you want to. It's a really bad idea, but you can. Because the assembler will just say it's a label. So you can't check for that. Here. Opcode. Assembler address. Well, do you know anything about opcodes yet? Not really. Can you check it? No, you can't. Therefore, if it's a valid token, it's okay. I mean, you can't check it now. Operand. Again, there's really nothing you can check. If it's a field and it's valid, or you know weird spaces somewhere, then yeah, it's okay. Here. If it's not a comment, it's invalid. Now you know that. So you print an error message. So I might have something like alpha. And say D1, D2. Negative. Well, this is an error, but it doesn't go there. If you comment it out, it's okay, it's a comment. But if it's not commented out, there can't be another token here. It's an error. So you have to think logically about what you can and can't have on any given line. Can I have a line that just says beta? Sure. So, you can't validate everything, but what you can validate, you should. All right. Late programs will be accepted with a penalty of 5% per day. Try not to turn them in late. Try to get them in on time. It's 5% per day, and the day starts at 2 p.m. when class starts. And finally, if I detect cheating, of course, then all of you will be in trouble the same way. So if somebody from your group cheats, the whole group gets an F. So don't do it. It impacts more than just you. When we've done file parsers in previous semesters, you call your buddy and say, hey, do you have a file parser? And he says, sure, here's my code. You think I can't find that? All I have to do is a search on my computer. I'll find it. So don't do it. I expect you to write this yourself. After this first project, of course, there's no code for you to copy. So it's pointless to even look. This first one you could find code to copy, but I'm strongly recommending you not do that. Each team will have code that looks very different. This is not code where it's all going to look the same. So, write it yourself. Work on it yourself. And understand as we go forward, if you haven't done one part, I don't know how you're going to do the next one. Well, you're basically learning C++ as you go here, most of you. And if you sidestep that opportunity, then when you have the hard code to write, you're going to be lost. So don't do it. All right, questions from anyone? No questions. Okay, read over this. Hit me with questions if you have them next time. And we will add, as we go, if you have questions, I will add them to the assignment so everyone can benefit from it. Okay. So, yes?
So for the header file, is that like an interface of Java?
It's similar to an interface. Yes. I mean, that's the idea. You have a prototype of all of the methods. Yes?
Okay, what about the make file?
You have to have a make file, yes.
Are you going to put like a template on it?
Yes, I will. I will. We need to talk about them. Make is a Unix utility. And it's designed to compile large projects. A compiler like Java is supposed to know what's changed and what's needed, but it doesn't always work. I don't know if you guys have had this experience, but the Java compiler isn't always able to figure things out. Sometimes you get compile errors when you know you shouldn't. And the solution to that is go delete all the class files, and then you get a clean compiler and it works. The Java compiler kind of does that, in a sense, but the C++ compiler doesn't do it at all. So you have to provide very precise instructions about compiling C++ code. And those take the form of a make file. It's, as I said, a Unix utility. It's not C++, it's Unix. And the idea is that it will look at the timestamps on the source code files and the object files, and it will not recompile things that don't need recompiling. So there's a chain of events, and you build all of the files that go into your project one at a time into object files, which is compiled but not linked. And then the final step is the linkage of all the pieces together to create a single standalone executable. Well, for this first project, how many pieces do you have? Well, you're going to have a driver, you're going to have a file parser, you're going to have a file parse exception. So you're going to have at least 3 source code files for this project. So you can't just compile one and then it will figure out what you need to do the rest of it. It doesn't work that way. So you create a file and you call it makefile, capital M. And and you have to follow certain rules for writing these files, which we'll talk about. And then at the command line, you just type make lowercase n, and it will read the make file and compile your project for you. So the beauty of this is once you have your make file written, then you just use it over and over, and it does the minimum amount of work necessary to recompile your project. For large projects, if you have dozens or even hundreds of source code files, it can take a long time to compile a project. And computers are much faster now than they used to be, but it can still take time. Large projects can take 30 minutes, 40 minutes, an hour to compile even on a fast computer. What we're doing here, this won't take too terribly long, but it won't be instantaneous. It's harder work than what the Java compiler does. So, but we will cover that. Other questions from you? Okay, so it seems to me that we were talking about arrays and pointers last time. Is that right? Okay, I want to talk more about arrays because you're going to need them. If you stop and think for a minute, this project you've got to do, how are you going to store this data? You're going to read this file and it's done. And now you have to look up selected pieces from this file. Line 60, token 2. Line 70, token 1. Give me a list of all the labels in the program. How are you going to do that? You go through and grab everything that's at index 0 in the second dimension. We have two dimensions here. We have rows and columns. It's two dimensions. There's another problem. If you're going to open and parse this file and read the data in, how big an array do you make? Is it possible to know how many lines are in the source code file before you process it? Not so much. So we have to read things and store things, but we can't exactly create an array in advance because we don't know how big it needs to be, which is an issue. So there are data structures that we can use, such as a vector. And again, we will talk about these. But I want to finish this discussion of arrays and pointers and point out some things to you. So I've got a little cheat sheet here. All right, so let's say in edit array.cpp. Now I'm using this convention that if it has a main method in it, it gets a CPP extension. Okay, so let's make this a little bigger here. So I need any includes, and if you're doing any printing, you need IO strings. That probably will do it, and you should always have using namespace std. That's not an std like some people catch when you're not being careful. It's standard library. Now, the main method, it should be in a driver program, but not in a file that has a class. You do not put a main method in a class. Not done. You don't do that in Java either, other than for convenience. So int main. And the main method can take two parameters. I'm going to go ahead and put these in so you can copy them. Now then, we also want return 0 at the end for successful completion. All right. So this is a double scripted array. It's a pointer, but it's a pointer to an array. So there aren't really two-dimensional arrays in C++, not like there are in Java. What you have is one dimension, but at that dimension it's got a pointer to the second dimension, if you follow. you can, so suppose we have this. We have ARR. Now this zero, 1, 2, 3. That is an array of pointers. It points to the other direction, to the next direction. So if you print this, and you can, you'll get an address. You'll get an address. So it's the address of the Y row. All right. Now, I like to compile often. So to do a standard compile with only a single file like this, you can do it manually. G++ minus O, that's the lowercase letter, the name of your executable. All right, so this is array.cpp, so let's call it array. And then the name of the file to process. And bang, we're good. So let me talk for just a second here about these command line arguments. This is the number of arguments. And this is a pointer to the two-dimensional array. This is the second, the next set of arguments here. This is going to be the file. And this is the total number of arguments that you have. Now note that the name of the executable counts. Java's not like that. So if this is, if you want to know how many command line arguments there are, you check this thing. So you'll have something like if argc is not equal to 2, print an error message. The 2 is the name of the executable and the single file name that follows. Those are the 2 arguments. So, okay. Now you can declare arrays several different ways. So let's say int ARR. Int ARR equals. This is just like Java. 2, 4, 6, 6, 8. So you can go ahead and supply the arguments right there. That is fine. You can do this. You can't do that in Java. This is not allowed. You have to use the keyword new when you make an array in Java. Otherwise, you have an error. Not the case here. Is this a valid array? Yes. Can I store something at index 4? I can. We're good to go. So there's a profound fundamental difference between Java and C++ about the allocation of memory. In Java, if you have an object, it must be allocated on the heap. You use the keyword new. Suppose we have a Java class person. Java class person. It exists, we wrote it up. And then I have person P. Is there any way in the world I can use P if I don't say P equals new person? Do I have a person unless I say P equals new person? The answer is no, you must. There is no other option. If you don't say P equals new person, then all you have is a null pointer, nothing else. You can't do p.setName. You can't do anything with it. It's just a null pointer unless you make it. You all with me? You know this, right? You can do this in C++, and in fact we do it all the time. So instead of Java, could we have a class person in C++? Yes, we probably wouldn't capitalize it, so we'll say person P. Now, can I do something with P? Yes. Suppose we have a set name method. Now, if we tried to do this with Java, we would get a null pointer exception. We would crash, right? What happens if we try it in C++? It works. Not only does it work, it's a good thing. This is not bad practice. It's a standard method of doing it. It works just fine. Yes, nothing wrong with that. 100% legal, good idea. You can also do this. Person. P2. Now I've done a star. This is a person pointer. Now this one's not a pointer. Completely different from Java. Java, this is a reference, and that's all it can be is a reference. Not so in C++. Here it's a person. Not possible in Java, but in C++ it is. This person is allocated on the system stack. So when you enter the method, the compiler reads through it and says, okay, I need room for a person, and it makes it right there. So there's a big difference between the two approaches. Here, this is what Java does by default. Well, not by default, it's all Java will do, we will not. It creates a reference. Here it's a pointer, but a reference and a pointer is the same thing, and that they both hold addresses. And now, you cannot say P.set, P2.set name. There you'll crash and burn. There is no person. You didn't ask for a person, you asked for a person pointer or reference. And that's it. So, I now have to say P2 equals new person. Now, P2 now look at this carefully. The syntax is correct. And it's the same class person. There's two ways to do it. This is way number one. This is way number two. It's the same person class. Both of those are legal, both are correct. What you actually end up doing, it depends. I don't know that there's a strong preference one way or another. A lot of C++ developers prefer to do this all the time. I'm not sure it's really necessary, but you'll see. Notice the accessor up here. He is not a pointer. We have the dot operator. Down here, P2 is a pointer. We have the arrow operator. This is a dash and a greater than. The arrow operator does the same thing, but you have to use the arrow operator if you are dereferencing something on the heap. So now let's draw a picture. Scenario number one. On the stack, we have P and P. It's a big chunk of memory, big enough to hold all the person data. And so when we do the next line, here we get John Smith, and so on. Perfectly legal. The second scenario, we have a stack, and on the stack, we have P2. Now P2 is a pointer, and on the heap we have the keyword new, and on the heap we have a person. This has an address, and it goes right here. So now when we say new person, this is created. P2 arrow set name. Go to ABC and set the name to John Smith. Both are acceptable. Either way works. The first one's easier. You just have to remember you can do it in C++. Because you guys all learn Java, and you think, I have to do this, but it's not true. You with me? Have I lost you? We're okay. All right. Now then, some fun with pointers. Yes?
Can you explain the arrow again?
Yes, this is an operator. This is an operator. So I don't really have any classes on here. I don't have enough code. But let's do another easy example. Let's do another one. Suppose I have class student. This is something I wrote up for you guys. I haven't posted it yet because I haven't talked about it. But I made class student, which is an easy class in C++. So we'll assume I say student S. Okay, I have a constructor in my class and it takes a single argument. And I can certainly do that. Looks funny, legal. Or I can say student star S1 equals new student John Smith. I can declare a student object both ways. Both ways are legal. Now then, print the first guy. That's not yeah. Print the first guy's name. Print the second guy's name. Dot operator if it's allocated on the stack. Arrow operator if it's allocated on the heap. So notice that S1's a pointer. S1's a pointer. So when we're using it with the arrow operator, there's no star here. That's not what you want. If you put a star in front of it, you get a compile error. You can't dereference something that's not a pointer. Like you dereferenced it, it's not a pointer. All right. Now, I need a different name here if I'm going to have this in let's see. So there's different ways that you can allocate and compile arrays in C++. But note that these two are not there's no meaningful difference between the second and the third, and in fact the first way of doing it. So let's try something. Let's do an assignment statement. ARR2 0 equals 1. ARR3 equals 1. That's not what I want to do. Okay, where's the brackets? Aren't any brackets? Is this legal? Yeah. Missing terminator. Whoops, what did I miss? Oh. By the way, you will come to appreciate how wonderful the Java compiler is because this one is not helpful. You will see error messages that are not helpful. Now I can see this one in a single quote was a stupid mistake. But sometimes you will see error messages that make absolutely no sense to you. Get used to it. Most compilers are that way. So you read carefully and think about it. And once you get the hang of it, it's better. All right. Now, Now what in the world is that? Star ARRT. There's no star. You see us, there's no star. What am I doing? Okay, let's try it. We got 1. How did we get 1 out of this? Where's the brackets? What's this star business? Anybody? Yes.
Pointing to the first element in array 2.
It is. Star is dereference. It starts at index 0, it printed 0. Exactly. Oops. We could do either way. So, in a loop, you can do this. So let's print this one. Let's go ahead and do this one. We'll write a simple for loop here. For sign I equals 0, I less than 4, I plus plus, C out, ARR, I, and I want to do some more here, star, ARR, plus I. Okay, see what happens. 2, 4, 6, 8. Both of these work just the same way. Notice ARRI, which is familiar. We also have star ARR plus I. Well, what is this? This is the way we used to do arrays before we had the square brackets. This predates the square brackets. We used to always do it this way. And then these came along, but these square brackets are actually operators. And they calculate the displacement from the beginning of the array. They calculate the displacement from the beginning of the array, which is how far down the line are we in array's contiguous memory. So suppose we have an array of integers, which are 32 bits. Then if I ask for ARR3, where is it? It is the address of the array ARR. This is an address, by the way, plus 3 times the size of the data, 4. So that element may be found in array plus 12. And that's what the square brackets do for you, is they look up the address of where it is. So far, so good. All right, let's do double scripted. Okay. So let's do a double scripted array. So I can say int r. And let's go ahead and say, let's get size, constant int size equal 100. Okay, int r size 4. Well, the 4 should be familiar. You've got 4 tokens on each line. So if you build something this way, size is the number of lines in the file, and 4 is the index of each token as we go along. So if you have, let's clean this up. If you have 4 tokens on every line, you have line 1, 2, 3, 4, and then you have tokens 1, 2, 3, 4, 1, 2, 3, 4, 1, that's what it would look like with your tokens in the file. So the first dimension here is size, and the second dimension is the number of columns. All right. So this declares an array of size lines in 4 columns. We can also do this. Let's see what else. Star, star, P. Okay. So it's a double dereference because it's a double scripted array. So this is what actually happens with this first declaration. P4. So we've made an array on the second dimension. Now I can say 4. 4 and j equals 0. J less than 4. P I J equals let's see here, J plus 1. Now I haven't done this one, but it works the same way. R0 or Ri equals min. I mean, they already exist in creation. So this is shorter and easier, and I don't suggest you always do this because these do the same things. Difference, of course, is I have to do the dimension, which I haven't. Let's just put it right here. Equals new int. Missing this. You have to make it, otherwise it's just a pointer. Well, this creates a pointer and creates it. With this R, you can reference the star star R. Now, if I do star star R, what would I print? Which element would be printed if I did cout star star R? Well, we haven't set it yet, but I can do it here as well. So let's add brackets so I can do 2 statements. We'll do both of them. R equals J plus 1. Okay. So we got 1, 2, 3, 4 like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's the data. All right, so if I print this out, what am I going to get? Save, let's see if it compiles. Cannot convert int star to star star. Why not? Of course not. The second dimension is not there yet. You have to go through and make it. That's what this is. So note that PI is a pointer. There's no star in front of it, but it is a pointer. All right, let's save the file and try it. Okay, so we did the assignment. So okay, let's try our print statements now. Cout star star R and star star P R.
star, star.
Seems okay. Not safe. There we go. R and P are 1 and 1. So of course, the guy is 0, 0. So we have, this is the way it gets stored in memory. It's a block of contiguous memory. And it does not look like this in the computer. What does it actually look like? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the first row. This is the second row. This is the third row. But they're right after each other. And in fact, you don't need the J to refer to it. You don't need that. So there's a formula for handling these two-dimensional arrays. It is the array ARR plus I times the number of columns plus J. And that will get you with just an I and a J, it will get you, you need, that's how you look it up in this row major order. So there is some good news in all of this. The square brackets that you're used to using work. It's not broken. You don't have to learn something different. However, if you're a C++ programmer and you have the ability to do this in so many different ways, then you should. You should. Okay, can we do this without the double scripts? So let's print, I don't know, R or P, the same thing. This is easy. Actually, not. We've got to go for 0 minus size plus. And then I'm going to do for J less than 4J plus plus. C out. Star. Star R. You need double dereference. R plus I times 4 plus J. And that should look up our elements. What's that?
Is before the return statement?
Return zero.
Yeah, I want to move this. Once you return, you're out of it. Easy mistake to make. Okay. Did not save in print time.
We're missing a semicolon on the for loop as well, Professor.
Well, I haven't saved it. It's modified.
So after the first row,
4.
there's
That's
a
okay.
semicolon. The first row loop,
I plus plus.
I is in there.
I equals 0.
I equals 0. You guys have memorized it. Okay, I'm going to abandon this in a minute. Alright. Did I save it? Let's see. I did. Okay. Now, I wish I could say I'm just testing you guys to see if you're paying attention. No, no. Here's your rows. 1, 2, 3, 4, 1, 3, 4, 100. All right. Now, of course, if you do something wonky, I'm going to take the dereference out. The star's the dereference. Well, it's a double scripted array. There's only one dereference. Well, C++ let me do it. It will. Addresses. That's what we got with the single dereference. Well, then you need to double dereference everything. So this is the same thing as if I was doing our, we've got single dereference rather than the double dereference. And if I go and do this, does it matter? Well, let's see. Does the placement matter? How about that? Yes, it matters. Because it binds more tightly than the parentheses. Okay. So I'm going to stop this and write on the board. That seems to be more profitable. But I wanted you guys to see how to compile and run these things. And notice when I did mistakes here on purpose, like this last one, obviously that's a mistake. It's not right. Did the compiler take it? Absolutely. Without a whimper. So, the real trick to C++ code is get it right the first time, rather than hack at it and try to debug it. Otherwise, you're chasing your tail. It's a fool's errand. I remember years ago I was at a conference in Atlanta, and Java was sort of new at the time. It hadn't been out a long time. And there somehow was this workshop I was at, there was just this bitch fest going on. It's just, oh my God, I don't know why they made Java this way, and how about the swing business is just nonsense. It's terrible. And the some developers that were there for Java, one of them said, well, you could just write it in C++. And the whole audience immediately went silent. Because the prospect of doing that was so unappealing that it stopped all the bitching. Yes. So, C++ is a wonderful language for some things, but not necessarily everything. All right, so a few more things about arrays here. First of all, arrays don't know how big they are. There is no r.length. It doesn't work. Therefore, you have to keep track of it. Now, if somehow you can't, let's say you're going to pass an array as a parameter into a function, you've always pass in the size as well. But if you don't have the size and you need to get it, the way you do this is you say use the size of operator. So you would do something like this. Size of. Now that size of, it's all one word, all lowercase, and it is an operator. It's not a function. It's not a method. It's an operator. Size of r divided by size of well, star r. What's star r? If you have an array r, single scripted array. Star r. What's that mean? So I made a declaration here. I'm out of order because int r. Okay, now you see it's silent. To look it up. Size of r. So that's how much room r takes divided by size of star r. Well, what's star r? Well, note that the star r is identically equal to which is the size of the whole thing divided by the size of one element tells you how many there are. That's how you can get the length. The easiest practice is to keep track of it. How big is this an array? Well, it's an array of integers. Okay, well, how many bytes is R? Well, if the size 100, then it has 400 bytes. bar is 400 bytes of storage space. Each entry of the 100 is 4 bytes in size, 32 bits. 100, so 400 divided by 4 is 100. So that's how you calculate it. You try not to have to do this, but if you have a method that takes an array as a parameter and there's no size, then this is how you do it. All right. Yeah, that's it. Okay. How do we eat up so much time? All right. Something important we need to do. We've had some rearranging. Is it really 3 o'clock? Yes, it's good. We've had some rearranging. Some new people. We now have 44 people in our class of 40. So I want you guys to get with your group so you know who all the new people are. And if you are, any of you are uncertain about your groups, please exchange contact information. So I'm going to run down these real quick. Alabama is Jesus, Stephanie, and Danielle, and that's it. So you guys don't have anybody there. Arizona, Jessica, Anthony, Nathaniel. California, I think we got somebody new. We have Francis, Joshua, and Aaron. Yes. Okay, Colorado, you don't have anybody new. It's Alon and Anthony. Florida, we have Tyler, Maria, and Ariana. Maria, Ariana, Ordona. Or is it Ordona? Which is it? Doesn't matter. Well, it is or it isn't. Is it an N yet or an N? I mean, I've known people from Mexico that are named Ordona. Is that how it's pronounced, or is it Ordona? Well, there were Spanish people there, right? Okay, so Ordona. I'll just call you Maria and move on. Indiana, Trevor, Tyler, and Luke. You guys are good. You got my message? And in Kansas is Kevin and Alexander and Michael. Where is Alex? Not here today. Cutting class. Minnesota, Joe Bren, Francisco Gracevina. So you guys are good. Missouri. Yep. That's the 2 of you, 3 of you. Anjan, Reggie, and Vivian. Cool. New Hampshire, you got somebody new. So the Nguyen's, Ben and Tuan, and Jung and Nok. You guys are in one group, okay? It's a bigger group, but we ran out of space. So. All right, Peter and Ruben. You're in New Hampshire. Nevada, Gabriel, Tuan, Patrick. New York, Robert, Nicholas, Jose. Good. Cody dropped, am I right? You guys know about Cody? Team Oregon. He was on your team.
He wasn't required for his major, he's a grad student. So
That doesn't count if you're a grad student. You don't get any credit for it. Yeah, okay. So I have Arthur, Justin, and Kafaji. Kafaji, how do you say it? I know I've asked you before.
That's my last name.
Okay. And in Utah, Kenny, Sinjin, and Aaron. You guys are good? All right, so take a minute and change information with the new people so you guys can get in contact.